Derivatives of inverse functions. Essential question. Can I find the derivative of the inverse of x at b comma a when I know the derivative of f at a comma b? Let's take a look at inverse functions. The linear inverse functions in this picture show that they are reflections over the y equal to x line. And notice that their slopes are reciprocals of each other. Now let's take a look at two functions that are reflected over the y equal to x line. This is y equal to f of x. Its point is a comma b. Now when you reflect over the y equal to x line, the x's and y's exchange, so this point, the reflected point, will be b comma a, and the function is f inverse of x. Now the only way we can have an inverse is if f is 1 to 1. In other words, it passes the horizontal line test. It has to be strictly monotonic on its entire domain, which means it's either always increasing or always decreasing. You can only have differentiability and continuity for the inverse if f is continuous on the domain and f is differentiable. Let's take a look at how we find the derivative of an inverse function. Here is y equal to f of x. And here's the point a comma f of a, or you could say a comma b. And we can find its derivative f prime of a. Now over here, this is the inverse, and we can see that the x and y have exchanged, or we could say b comma a. And the slope of the tangent line will be f inverse prime at b, or f of a if you want. So these two will not be equal to each other, they will be reciprocals of each other. All right, let's take a look at inverse functions and realizing their slopes are reciprocals of each other. So here's the function f of x equals x squared on this limited domain so that it could be monotonic, and here's its inverse. All right, here's the derivative, and here's the derivative of the inverse. We're going to evaluate it at 2, 4, because 2, 4 is a point on f of x, and when we evaluate it at 2, we're going to get a slope of 4. Now here is 4, 2, which is a point on the inverse function. When I evaluate it at 4, I put 4 in here and I get 1/4. So you can see that these two slopes are reciprocals of each other. Let's do it one more time. Let's do it at 3, 3, 9, and 9, 3. Put 3 back into the function up here, and its derivative, its slope will be 6. And let's go ahead and put 9 in here, and when you put 9 back into the derivative, you're going to get 1/6. So this establishes the idea that they have reciprocal slopes. Okay, let's go ahead and do a problem where we go ahead and find all this information. So we have f of x equal to 1/4 x cubed plus x minus 1. And we don't really need to know what the inverse looks like. But we are being asked to find what the value of the output is when you put 3 in. So we're being asked to do that. Now, this tells us, which means that x equal to 3 is an output for f. Remember, they exchange places. So I'm going to put a 3 in here, and I'm going to have 1/4 x cubed plus x minus 1. 0 equals 1/4 x cubed plus x minus 4. And the x that works is 2. Okay, so I know the point 2, 3 is in this function, and I also know the point 3 comma 2 is in this inverse function, even though I don't know what it looks like. Okay, I'm going to find f prime of x, because the second part of the question says to find the derivative. F prime of x is equal to 3/4 x squared plus 1. I'm going to evaluate it at 2, and when I evaluate it at 2, it's going to be 4. Now I want to find the derivative of the inverse at 3, which means it's 1 over f prime at 2. and I figured out f prime at 2, and that's going to be 4, so this will be 1/4. And notice that these slopes are reciprocals of each other. So as soon as you find one, you know the other one. Okay, let's go ahead and do another problem where there's no graph. We have this function. Well, we don't have to know what the inverse function is, but we are being asked to find the derivative. I should have written this. I'm being asked to find the derivative at 1, okay, which means 1 is an output. So I'm going to put 1 in here, and that's x cubed minus 4x squared plus 7x minus 1. 0 equals x cubed minus 4x squared plus 7x minus 2. And use whatever means you need on your calculator to figure out what x is, and I figured out it was 0.156, so it's not a nice number. And I know that I can figure out the derivative at that point. It's going to be, the derivative will be 3x squared minus 8x plus 7. And then when I evaluate at 0.156, I'm going to get 5.823. So round to 3 decimal places. That's the established criteria for AP exams. So if I want to find it at 1, and this point right here is 1 comma 0.156, and over here the point is 0.156 comma 1 right here. So I'm going to do 1 over f prime at 0.156, and when I put that in, it's going to be 1 over 5.823. And if you want to divide it to find that decimal, that's okay. Otherwise, we're done. Okay, let's do another problem. And similar to what we had here before, here's the function. We don't know what its inverse looks like, nor do we care. The derivative at 3, this means that 3 is an output. So I'm going to put 3 equals e to the x plus the natural log of x. 0 is equal to e to the x plus the natural log of x minus 3. Use whatever means on your calculator to figure out this answer. And I got x to be approximately 1.074. I'm going to find the derivative, which is e to the x plus 1 over x. I'm going to evaluate that at 1.074, which is going to be about 3.859. So I've established that the point is 1.074 comma 3. That means this point will be 3 comma 1.074. To find the derivative at 3, it's going to be the 1 over f prime of 1.074, which is going to be equal to 1 over 3.859. And you can go ahead and put that in your calculator or leave it that way. Okay, let's take a look at something with a table. All right, we want to find the derivative of the inverse of g at 1. The derivative of inverse of g at 1, which means 1 is an output for g. So this is going to be 1, and that's going to help me find here at 1, if the output is 1, then x must have been negative 1. So this point is negative 1, 1. This point will be 1 comma negative 1. These are going to be the reflected points. Now g prime of negative 1, I'm going to use my table. Here's negative 1, and g prime is negative 1/5. So to find the derivative at 1 would be the reciprocal of 1 over negative 1/5, which means it's negative 5. And here's the answer. Now the b part wants us to find this, so I'm going to have to go back over here, and my g of x, my output is now negative 3. So I look over here on my g, negative 3, so my x is equal to 4. I want to find g prime of 4. I'm going to go back to my table. G prime of 4 is negative 2. So this point right here is 4 comma negative 3. Over here the point is negative 3 comma 4. This will be 1 over g prime of 4, which is going to be 1 over negative 2. And there's my answer. Okay, now your turn. Go ahead and stop the screencast, see what you can do, and the next slide is the answer. Here's the answer. Your turn again. Go ahead and take a moment to stop the screencast and then read the answer. And here's the answer. One more time, take a moment to find the answer to this. Stop your screencast. And here is the answer. Looks like I have one more. Here's one last problem. Stop the screencast, see what you can do. And here is the answer. This is the end of the screencast.